Alright, so let's take a look at these arithmetic sequences in context of recurrence relations. So we've already known that D is the common difference, the thing that we're adding or subtracting. So two ways this can look in a recurrence relation. Here's the first. UN is UN minus 1, so current is the previous term plus D. Okay, remember D can be positive or negative. Or we can use the other notation, the next term is the current term plus D. Either way, to get to the next term, I add the common difference, which is the definition of arithmetic. So here I've got an arithmetic sequence, 10, 7, 4, 1. Okay, and we're asked to determine the first order recurrence relation. Meaning, remember, whenever we state a recurrence relation, first thing I need is the first term. I'll use U1. And then the second thing we need is the rule. Without both of those pieces, it's simply not a recurrence relation. U1, well, that's the first term. I've just got that sitting right there. U1 is 11. Now for the rule, I need the common difference. I just need to fill it in that equation there. Now looking here, when I go from 10 to 7, that's minus 3. 7 minus 10 is 3. When I go from 7 to 4, that's again subtracting 3. And when I go from 4 to 1, that's subtracting 3. So therefore, D is negative 3. Once I've got that, I just need to fill in my rule. So UN, the current term, is the previous term, minus 3. And that's all I need to do for that one. I've got my starting term, I've got my rule, so I'm done. Okay? If you wanted, okay, you can use the other formula as well, that these are both completely correct. Okay, so the starting term and then the rule, again, does not matter which one of these you choose. They are identical. So let's take it up the next level. Instead of being given the sequence explicitly, I'm given it in terms of a different type of formula. So here, determine the first order recurrence relation for the sequence defined by UN is 4 minus 3 times n. Now notice here it's just n, the term number. It's not UN minus 1. Okay? It says for n equals 1, 2, 3, 4, and so forth, where n is the term number. So to get the first term, I'm going to put 1 in for n and simply evaluate that. To get the second term, I'll put 2 in for n and so forth. That'll generate my sequence, and then from there I can do exactly what I did in example 2. So let's give that a go. If n is equal to 1, well, U1, that means that's 4 minus 3 times 1, or 4 minus 3. So my first term is the number 1. My second term, n equals 2. U2, 4 minus 3 times 2. That's 4 minus 6, which is negative 2. When n is equal to 3. So this is just an alternative way to generate the sequence. Okay, this is called the general form versus the recurrence form. So U3 is 4 minus 3 times 3, 4 minus 9, which is negative 5. And the lucky last, I can stop now, but just so I have a few terms to work with. Make sure I didn't make any arithmetic errors. So just putting 4 in for n, that's 4 minus 12, or negative 8. So now I've got my sequence here. So my sequence is 1, negative 2, negative 5, negative 8. Once I've got my sequence, I do exactly what I did up here. It's actually going to be nearly the same recurrence relation because I'm also decreasing by 3. Okay? So my rule will be the same, but my starting term will be different. So let's give that a go. So, as I said, 1 to negative 2, that's subtracting 3, subtracting 3, subtracting 3. So D is -3. So I'm just going to do it in one of the formats. So U1 is 1, because that was my first term. When I put 1 in for n, 4 minus 3 is 1. And let's go with this one. -3. Everyone always likes it when your answer is in a box. It makes it nice and easy to find. So that would be our recurrence relation from that general form. So we can use this other format to generate the sequence. And then once we've got the sequence, this guy here, once we've got that sequence, then we can go to the recurrence relation. So whether we're given the sequence explicitly, like here, or we have to generate it, the steps are the same after that. Alright, well done.